Okay, so I'm just going to run through a couple slides and then I'll show you a quick demo. Uh, okay, so basically the thing that Pfizer added into tranSMART is support for genome-wide association studies. I'm sure that most of you on the call understand what these are, but fundamentally, I've got the definition from Wikipedia. Basically, they look for allelic differences between cohorts of subjects that exhibit a certain trait versus those who do not. And for example, it could be a disease-related trait. And fundamentally, one of the ways to visualize these is looking at a Manhattan plot, which is described here, where chromosome positions are on the x-axis and a negative log p-value. So the p-value of the difference essentially between the odds ratios for each cohort, for each individual variant. Typically these are single nucleotide polymorphisms, but that p-value is going to be on the y-axis. And in this case, you can see in chromosome 6, there looks like a region that has some substantial significance for particular SNPs for whatever cohorts were used in this experiment. So basically, a couple of years ago, our business groups came to us and said, you know, we're really interested in GWAS. We're using this type of genetic information to try to select our targets. And it would be great if we had a centralized system and a Manhattan plot viewer associated with that. So at the very least, we need a database. And actually, there's a product that I believe was created by Brian, probably your group, in University of Michigan called LocusZoom, which provides some of the functionality where basically you feed it the data and it'll come back with a Manhattan plot, say through email. And that was the minimal that we needed to produce. But we looked at our opportunity with tranSMART. We decided to enable this type of capability within tranSMART, and that would be good for our customer groups moving forward. So we worked with Converge, well then Recombinant. We leveraged the faceted search to provide a visualization and presentation of this data within tranSMART, and we built a fit client for the Manhattan plots and called the Genome-Wide Association Variant Analyzer, or GWAPA, and I will demo both of those today. Basically, what we're finding is that in general, people are telling us that they're saving weeks in terms of applying genetic information within the context of target selection. But at this point in time, we have over 500 individual GWAS analyses representing approximately 2.5 to 3 billion records in our database. Over 300 of these are imputed and have approximately 8 million SNPs associated with the summary statistics. They're used across many of our research units, and we also can represent expression quantitative trait loci, as well as metabolomic associations, although I won't demo those today, specifically demo those today. So I'm just going to end. There was a number of people who have been involved over the last couple of years, but I certainly want to give standout to Converge Health, who did basically all of the programming for us. And on our business technology side, Peter Henstock was the person. He's one of our he's actually a very, very good programmer, but a statistician by training, and he actually built the GWAPA tool that you'll see. Ami Kandeshi, who recently left the company, but she was our technical lead for quite a while and worked with Terry to try to get this in. And really call out Haiyan Zhang and Hugo Berube. Hugo is our new technical lead who took over for Ami, and they've been instrumental to try to ensure that this was working for the foundation. Okay. So what I'll do first is I'm going to pull up tranSMART. This is the Oracle version of the Foundation's tranSMART, and what you're seeing here on the GWAS tab is essentially a view that on the left-hand side there's the faceted search filter, and on the right-hand side are the various GWAS analyses. So you can use the filter to get at the analysis that you'd like, and again, there's only a few here, but you can go in and search by a particular study. I'll pick this one, MAGIC, which is an open source, publicly available data set. So I'll select that. And If I go in there, I can see the magic analyses, and I can further restrict either from the browser, or if I just click the ones that I might be interested in, fasting glucose and fasting insulin. I'm sorry, hit the wrong button. But if I pick these both, add to the selected filter, basically I'll see these analyses. If I open these up, what I'll see first and foremost very, very quickly is the top 500 most significant SNPs in any of these analyses. And you see that there's a number of values that can be associated with these GWAS sets. The GWAS sets are actually loaded through, we use a standard format, and there's actually a loader in this upload data tab. I won't demo that today, but basically you can load these sets directly from tranSMART. And unsurprisingly, basically what you see is, of course, individual SNPs, the p-value associated with them. And in this case, they are in order of most significant first. And we also have things like the gene, if they are in a gene region, whether they're in intron and exon, if that's the case, as well as the chromosome position. All right. And basically, if you want to see the Manhattan plot, you can click Manhattan plot. And because it takes a little time, I have this already set up. And what you're seeing here is GWAS, which will launch directly from tranSMART. And actually, you can launch GWAS on its own. Basically, it uses web services to get at the data that is within tranSMART. And I'll just give you a very, very basic demo. So if you look at, let's go back to tranSMART for a second. If you look at this fasting glucose analyses, you can see that this G6PC2, this gene was very highly significant. So basically what you can do with GWAS is you can select your available models, in this case the magic models, and you can give it either a list of genes or RSIDs, and you click retrieve data. When the data comes back, as it is done for this G6PC2, what you can do is you can see the results, in this case on a color plot. So the right-hand panel here will list all the analyses that are retrieved. You can click on this, click the color plot, and what you'll see is this region where around this G6PC2, in this case, you can select the flanking region within the query, and you can modify that. By default, it's 100,000 base pairs. And basically, you can mouse over the SNPs, and you can get further information on any one of these. And this was a meta-analysis, so for the folks who are seeing these very, very significant p-values, it's because it's a meta-analysis. And you can do some other basic things, such as you can zoom in to regions, of course, zoom back out, and we'll go back to the original. Additionally, you can do things like add lines. So if you had an interest of saying, I'll call it my line, and I'll put in a p-value, a negative log p-value of 50, and it'll put in lines so that you can easily see, and little tricks like that that make this relatively easy to use. You can also put in shading for gene regions. Additionally, although there's not any in this position, we also have loaded recombination rate, and where it's available for positions within the genome, you'll see the recombination rate as well. All right, you can also view this as a thumbnail plot, and what's interesting is, unfortunately, I don't have more than one model selected, but basically, you can add in multiples of multiple analyses if they're on the same genome region into this interactive Manhattan plot. So you can see multiples and you'll see color differentiation. You can also view these as in a thumbnail format. Basically, if you're looking across or looking at varied regions in the chromosome, you can present these and it will normalize all of the plots on the y-axis. So you can look across, and you can do things like resize, and you can get put a number of these plots together, and again normalized on the y-axis. The last thing that I'll show you that you can do that I think is interesting in terms of just being able to get at the data in a tabular format. Go to a table view, and right now I'll remove everything. And basically, I can select a model of interest and include all of the data. So here's all the data that's associated with that particular model. I can, for example, maybe pick a p-value. Say I'll go a p-value greater than negative log p-value greater than, say, 10. I can remove everything else. Actually, I'm going to up it a little bit. Again, this is a meta-analysis. I'll say p-value 50, negative log p-value 50. And I can very easily go in and restrict these data and be able to export that out into the limited files. But it's a nice, easy way when you have to be able to get at these data quickly and subset these data very, very quickly, especially if you're viewing multiple of these models. So I think I'm going to end there and see if there may be any questions, but just a little taste of what you can do with the GWAS capabilities within tranSMART 1.2. Thank you very much.
Okay, I'm unmuted now. Hey, Jay, this is fantastic. We see immediate use for this. Do you identify variants and output in the VCF format?
So right now we don't. That's actually a great requirement. Right now we only export out in a delimited format, so a CSV format.
Okay, yeah, that'll be something maybe we can put up for further work. I mean, I'm very excited about using this tool here in Michigan, and I'm sure it's going to see broad use throughout the community, and it's going to be a big highlight for us. And seeing how we can integrate this with other tools, we've got a nice pipeline we've developed where this GWAS would be part of it, and we'd be happy to share that capability with the community at the upcoming international meeting in mid-October. Thanks so much for this. This is a great contribution.